Welcome to another Mr. Paul video. Today we're talking about 7.2, equations with the distributive property, okay? And what this means is we're still discussing equations with variables on both sides, but what happens if we need this extra tool? What happens if we need to use something what's called the distributive property? Now the distributive property I put under the list of goals that we had from the previous video because these previous three goals are listed here, right? Variables on one side, constants on the other, 1x is equal to something. But occasionally an expression or a mathematical equation would need us to do a little bit something else to make it so that it's easier to solve, to make it so we can solve it. We need an extra tool in our toolbox. So the distributive property basically says if you have something like, I don't know, 2 times 5 plus 3. Okay, we're going to ignore this top equation for a second. In math, what we were taught to do is PEMDAS, right? We would do this this addition first, and it would be saying like 2 times 8, which is 16. Okay, 5 plus 3 is 8, and then 2 times 8 is 16. What the distributive property says is it gives me an opportunity to rewrite something. It gives me an opportunity to rewrite something. So what the distributive property says is if I have A, B, and C, which are numbers, and it's in this exact format, where A times B plus C, I have two numbers being added together, and that's being multiplied by a number. Just similar in a way, two numbers are being added together, and it's being multiplied by a number. I can rewrite it as A times B plus A times C. What it's basically saying is take A and multiply it by the first number added to A times the second number. Now, it's also true for negatives. The only difference is if you have numbers that are being subtracted together, you're going to be subtracting the number in the middle. So it's A times B minus A times C. Now, I really want to stress that the distributive property doesn't solve math for us. It only allows us to rewrite it. So, for example, if I wanted to take this math equation, I want to know what this is equal to, it's equal to 16. Now, if I was to use the distributive property instead, it would look something like this. 2 times 5 plus 3. I would take the 2, I can rewrite it as 2 times 5 plus 2 times 3. I'm taking the 2 and multiplying it by the 5. Okay? Similar in a way, it's A times B. So it's A, B, and C. A times B, so it's 2 times 5, plus, similar in a way that it's plus, A times C. So A times C, 2 times 3. 2 times 3. 2 times 5 is 10. 2 times 3 is 6. And they're being added together. 10 plus 6 is 16. But Mr. Paul, this is 16. This is 16. This looks way easier to me than this. And I agree with you. That is a fair statement. That is very true. But oftentimes when we use the distributive property, it's not on something that looks exactly like this. As a matter of fact, oftentimes when we use the distributive property, it's on things that we don't know. So for example, 5 times 2x minus 1. We would use the distributive property when we can't add the things or subtract the things in the middle. 2x minus 1, I can't take away 1 from 2x because I don't know what the value of x is. But I can rewrite it. And that's what we're going to be incorporating into our equations today. So in our first equation, you'll see that we have a setup that is asking us, please rewrite to something more useful. And you'll see what I mean. If I have equations on variables on both sides, the 2x and the 3x, they're on both sides of the equation. I have constants in the -1, the 2, and the 14. And I want to get them separated. If you're not sure what I'm talking about, watch the previous videos. I want to get them separated, but I can't take away 2x from both sides because this thing is already being multiplied by a number. I'm stuck unless I use the distributive property. Now, what the distributive property says is if I rewrite this section, I'm only going to rewrite this, okay? So I'm going to take the 2 times it by 3x and then take away from 2 times 1. I'm going to rewrite it using this bottom half of the distributive property. It's one rule, but it applies to both positive and negative. And I can rewrite this side of the equation. Remember, I don't care what's happening over here yet. I'm only rewriting this piece. 2 times 3x minus, 2 times 3x minus 2 times 1. And if I'm going to continue to rewrite it, 2 times 3x, 2 times 3 is 6x, and then minus 2 times 1 is 2. So I can rewrite this as 6x minus 2. So let's think of this equation as 6x minus 2 is equal to 2x plus 14. Once I've rewritten this side using the distributive property, the math problem becomes something I've seen before. An equation with variables on both sides. This time I don't have this sticky situation to deal with. So let's rewrite the problem, but with this time use the rewrite. So we have 6x minus 2, that's what this side is rewritten as, 2x plus 14, 2x plus 14. Now I can use my 3 goals. I want variables onto one side. I'd rather take away 2x or 6x. I think I'd rather take away the 2 to make sure that my variables are all positive. Although it doesn't matter. I'm doing the same thing to both sides. So 6x, take away 2x is 4x. And then I didn't touch the 2, so it's still there. 2x, take away 2x, those cancel, and that's equal to 14. Okay, well, variables are onto one side. I want the numbers, the constants, onto the other. I don't want this negative 2 here, so I'm going to add 2 to both sides. 4x plus minus 2 plus 2, those go away, so I'm just left with 4x on one side. 14 minus 2, or 14 plus 2 is 16. 4x is equal to 16. Variables are on the left, constants are on the right. First 2 goals are accomplished. The last goal, 1x equals something. 4 times x, nope. 4 times x divided by 4, 16 divided by 4. I want to get to 1x. 1x equals 16 divided by 4 is 4. What this is saying is when x is equal to 4, both sides of these are equal. And we can check our work. We can check our work. Okay? X is equal to 4. So 3 times 4 is 12. 12 take away 1 is 11. 11 times 2 is 22. 4 times 2 is 8. Okay? Remember, x is 4. So 2 times 4 is 8. 8 plus 14 is 22. Both sides are equal to 22 when x is equal to 4. This involves the 3 steps that we did with equations with variables on both sides. We needed this extra tool to deal with this side using the distributive property. Okay, let's try another example. Example number 2. Suppose we have 3x plus 6 equals 3 times 2x minus 3. This time, we have variables on 2 sides in the 3x and the 2x. We have constants in the 6, the 3, the negative 3. But once again, I have a situation where I have a number being multiplied by something that's being added or subtracted. I need to use the distributive property because I can't straight start subtracting anything from both sides until I do. So I'm going to do 3 times 2x, and it's a minus, so I'm dealing with the minus 1 again. 3 times 3. So I'm going to worry about just this side for a second and rewrite it. What would this be if I rewrote it? So 3, the first a times b, which is 2x, minus a times c, right? A times c. Well, 3 times 2x is 6x, minus 3 times 3, which is 9. Oops, which is 9. I can think of this side as 6x minus 9. So let's rewrite this whole thing. I'm going to keep this side the same. It's okay for me to deal with. But this side I'm going to rewrite as 6x minus 9. Remember, distributive property only rewrites stuff. So 3x plus 6 equals 6x minus 9. Okay. Now I can get to work on my 3 goals. I want variables onto one side. So I could choose the left or the right, but would I rather take away 3x from both sides? Would I rather take away 6x from both sides? I'd rather deal with positives, so I'm going to take away the smaller of the 2. Minus 3x, minus 3x. Whatever I do to one side, I will do to the other. 3x, take away 3x. they cancel, they go away. All that's left on this side is 6. 6 minus 3. So 6x minus 3x is 3x. And then I didn't touch minus 9, so it's still there. I have variables on the right, which means I want the constants on the left, meaning I don't want this negative 9 here. To get rid of a negative 9, I add 9. I'm going to add 9 to one side, add 9 to the other side. Whatever I do to one side, I got to do to the other to maintain that both sides are equal. 3x minus 9 plus 9, they cancel. All that's left on this side is 3x. 6 plus 9 is 15. 3x is equal to 15. My variables and my constants are now separated. I want to 3 times x. I don't want 3 times x. I want 3. If it's being multiplied by 3, I'm going to divide by 3. And divide by 3. Because again, I want 1x. 3 divided by 3 is 1x. Okay, 15 divided by 3 is 5. What this is saying is when x is equal to 5, both sides of the original equation should be equal, and we can check our work. Assuming x is 5, this should be a 5. 3 times 5 is 15. 15 plus 6 is 21. 5. 2 times 5 is 10. 10 minus 3 is 7. This entire piece is 7. 7 times 3 is 21. Both sides are equal to 21 when x is equal to 5. We have 2 more examples of using the 3 goals to help equations with variables on both sides, but these 2 needed an extra tool to help us deal with stuff that's being multiplied inside some parentheses, called the distributive property. That's all for today's video. I hope these help. Peace.